All right, guys. So let's get into the next part of our unit, which is all about radicals. All right, so today's lesson, we're going to be focused on what we call a radical. So a radical is, I'm going to type this above here, a radical is another name for a square root. Okay, so you will see a radical symbol. We'll talk about that here. That's what we're looking at here. It's our square roots. Okay, so we can talk about it in another way when we have, say, the square root of 4. We are going to read that as radical 4. Okay. So we are going to read the square root of 4 as radical 4 or as root 4. Okay, so you're going to hear it in a couple of different ways. All right. Now, what it comes down to is our perfect square roots. Okay, we know that 4 is the same thing as 2 times 2. Okay, so we know that the square root of 4 is just going to give us 2, because what we're looking for is what number are we multiplying in order to get the value inside? What number are we squaring to get the value inside? Now notice how when I went from the square root of 4 to just get 2, I don't have a square root anymore. Once I get rid of the square root, once I take the square root, that radical goes away. Okay, so when I look at radical 81, I think what number squared gives me 81? That's 9. Okay, 256. You can type this into your calculator if you need to. Use Desmos. The square root of 256 is 16. 16 times 16. 121. You should know that one pretty easily. That gives us 11. 324, you might not know that one. That actually is 18 squared. Okay. And the square root of 1, we know the only way we can get 1 when we square something is if I'm squaring 1. Okay. So again, I'm looking for what am I multiplying here? What am I squaring here to get the value underneath? Okay. Once I take this square root, that square root goes away. Okay. Now, if I have a fraction, the same type of thing holds, except actually what we're going to do is another way to look at it. When I have the square root of 64 over 18, I can look at this as the square root of 64 divided by the square root of 81. Sorry, not 18. Okay, square root of 64 divided by square root of 81. Square root of 64 we know is 8. 64 is 8 times 8. And square root of 81, 81 is 9 times 9, so that's 8 ninths. Okay. Same thing with number 8. I can rewrite that as the square root of 1 divided by the square root of 16. We already know that the square root of 1 is just 1. And the square root of 16, 16 is 4 times 4, so that reduces to 1/4. Okay. All right, so again, same thing with numbers 9, number 10. Number 9, that's going to reduce to 3 over 10. And number 10, that's going to reduce to 5 over 7. Now, every single one of these was a perfect square. All right, you need to know your list of perfect squares. All right, that's extremely important. We talked about these before. Your list of perfect squares. We have 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Now, I suggest that you know the next 5 as well. Okay, your next 5, I'm going to change my height here. Okay, your next 5 are going to be 121, then 144, then 169, then 196, and then 225. All right, so those are your first 15 perfect squares. And how we get these perfect squares: 1 is 1 squared, 4 is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and all the way up to 15 squared. Okay? Now, if we take a look here at these next ones, it says we're going to simplify non-perfect square root radicals. Okay? So if we look at 24, 24 is not in our list. Okay? But what I'm going to do is I am going to look at my list and I am going to divide this number by the biggest number that is smaller than that. Okay, 24. The biggest number that is smaller than 24 is 16. And you're going to check in your calculator. If I do 24 divided by 16, do I get a whole number? Meaning, do I get any decimals? 24 divided by 16, we get a decimal. So that's not the number we want. 24 divided by 9, I get a decimal. Not the number I want. But if I do 24 divided by 4, I get 6. So what we're going to do is we are going to rewrite this, because 24 is just 4 times 6. So I'm going to rewrite this as the square root of 4 times the square root of 6. Because when I multiply my radicals, I multiply the numbers inside. Okay? Because, this is just another way to write it. Well, what's nice is 4 is a perfect square, right? We talked about it. Square root of 4 is the same as 2. So what I can do is I can just rewrite the square root of 4 as 2. And the square root of 6, it's not in our list, so it has to just stay. Okay, that comes down. All right. I can do the same thing here with 48. I'm going to start with the highest number less than 48, which is 36. I do 48 divided by 36, I get a decimal. 48 divided by 25, I get a decimal. 48 divided by 16, I get 3. So that means that square root of 48 can become the square root of 16 times the square root of 3. Now I'm putting the number in front that is the number in my list, okay, because that's the way that it reduces really nicely, right? 4 was the number in my list, so the 4 went first. 16 is the number in my list, so the 16 goes first. Now we know the square root of 16 becomes 4, and then the square root of 3 is going to just come on down. Okay? Let's do the same thing with 72. With 72, I'm going to start with 64. Okay? 72 divided by 64, decimal. 72 divided by 49, decimal. 72 divided by 36, I get 2. So the square root of 72 is just going to be the square root of 36, because that's the number in my list, times the square root of 2, because 36 times 2 is 72. Square root of 36, it's the 6th number in my list, so square root of 36 is 6, and the square root of 2 comes on down. All right, let's keep on going here. Okay, let's take a look at number 15. Okay, 15. Now we're on the other page, but we're not going to do anything different. I'm starting with 175. So 175, I can start with 169. I get a decimal. 175 divided by 144, decimal. 175 divided by 121, decimal. Divided by 100, decimal, decimal, decimal. And you keep going down until you get to the number that works, which in our case is 25. So I get 25 is the number that I need, and it's 25 times 7. So I have the square root of 25 times the square root of 7. Now notice, I'm only dividing by these numbers in my list. I'm not going to divide by any other number. I can only use these values. So the square root of 25 we know is just 5, and the square root of 7 is going to come down. Okay, so it doesn't matter if you have really big numbers. You use the numbers in your list. Okay, I can use 300. Okay, I'm going to start with 300. Can't divide it by 225. Can't divide it by 196 or 169, 144, 121, but I can divide 300 by 100. It's 100 times 3. So the square root of 300 becomes the square root of 100 times the square root of 3. 100 is the 10th number in my list, so the square root of 100 is 10, and the square root of 3 follows down. All right, couple more here. Square root of 63, so I'm going to look at my list, start with 49. 63 divided by 49 doesn't work. 63 divided by 36 doesn't work. 63 divided by 25 doesn't work. 16 doesn't work, but 9 does. Okay, oops, wrong one. So 63 is 9 times 7. So that's square root of 9 times square root of 7. The square root of 9 just becomes 3, and the square root of 7 comes on down. Okay. Let's do 2 more real quick. So the square root of 343, again, you're going to go down your list. Keep on going down your list until you find the first one that gives you a whole number, no decimals. 343 divided by 225, 343 divided by 196, you keep going down, and the one that works, or the first one that works, is 49. So I have the square root of 49, and it is 49 times 7. Square root of 49 is 7, and the square root of 7 comes on down. Okay? So that is your simplifying radicals. Underneath there it says your summary. Okay, so I'm going to write your summary out here for you. So your summary is that radical is another name for a square root. Perfect squares are the numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Those are your first 10. Then we have 121, 144, 169, 196, and 225. Those are your first 15 perfect squares. Okay. To simplify, non-perfect square roots. Non-perfect square roots. Find the greatest, if possible, right? If it's possible to find the greatest one, find the greatest square root that goes into the number under the radical. Okay, so like we just did here, we had 343. The largest square root that I could divide by was 49. Okay, so that's how we reduce our square roots. Make sure that you work on your homework for this evening. Okay, and be ready for another video.